Hello and welcome to another video on linear growth and an application of linear growth. So let's consider a population of monkeys with an initial population of 400, and each of the next 2 months the population is recorded as, for the first month, 445, and the second month, 490. So if it continues to grow at the same rate, find an explicit formula that can be used to predict the population in the future. So notice that we go from, let's just make a table here. So the month, let's call it n because they say n here, and then the population. At month 0, the initial month, there was 400. That's what this represents. And then after 1 month, it's at 445. So if you just look at we already said this was linear growth. So if you look at what happens, the 445 minus 400, that's an increase of 45, right? That went up by 45. And then after the second month, after 2 months, after 1 more month, that went up to 490. And so that also was an increase of 45. So that's the constant difference, isn't it? That difference is constant. That's what we call the constant difference, is 45. So P sub n, a formula should involve the initial amount, 400. So in general, we are accustomed to, and I'll remind you, you're probably used to y equals mx plus b, where b is referred to as the y-intercept, or the starting point. M is referred to as the slope, or in general, the rate of change. So in this case, instead of y, they're using p with a subscript of n to tell you which month it would be, and that's equal to, it starts out at 400, right? So that's our b, or in general, we could also call that p sub 0 is the starting point, just kind of like b, these are correspond, plus, and then we use d for the constant difference, that's like the month, we talked about that, and then n is our variable like x. And so P sub n is P sub 0 is 400. That's how it starts, with 400. And then you add, it looks like 45 times, that would be monkeys per month, 45 new monkeys or more monkeys per month times the number of months. And so there's our formula. And then after 15 months, we're just going to basically plug in P sub 15 would be where you plug in 15 for D. So that's going to be 400 plus 45 times 15. So 400 plus 45 times 15 is, I'm getting 1,075. Let me double check that. 400 plus 45 times 15. 1,075. Okay. Now it says, use your explicit formula to find the number of months until the monkey population reaches 1,000. Now this assumes the monkey population grows at the same rate the whole time, which is not that practical in reality. It's not that practical in reality. So in this case, this is our p-value, p sub n, which we don't know. So that's 1,000 is equal to 400 plus 45 times n, the number of months. Now we don't know what that is exactly, but we can guess it took 15 months to reach 1,075. So to reach 1,000, it must have been before 15 months. A couple months before that, probably around 13 months, because at 45 a month, that would put you over 90. So if we do this, solve this equation, of course, for n, we have to subtract 400 from both sides. So that gives us 600 is equal to 45 n. And now, of course, we're going to divide both sides by 45. And that will give us actually. 13 point, what, 600 divide 45 is about 13 point something. 13.3 repeating. Oops. 3 repeating. So let's see if this will allow us to just, if that'll take 13.3, let's, or we could write 13 and a third, but I'm going to go ahead and exit that drawing and say, okay, this is about, let's just look, 13.3. Let's see if it'll take it rounded off. Okay, this was 1075, and this we know was 400 plus the 45n. I guess I'll put in the times n just to be cautious, although I know typically WAMAP doesn't require that. We submit that. Yeah, it didn't like the 13.3 months, so we should be a little more accurate. So I'm going to write 13, and I'm going to try. Let's try several 3's and see what it does with several 3's. It'll probably give us credit if we get it that close, which it does. You also could have, let's see if it'll take 13 and a 1 over 3. Oh, it says decimal or integer value. So it wanted the decimal value. So probably 3 places. Let's see if it'll take it with that. Yeah, even 3 places was good enough. So the nearest thousandth. So don't skimp on the decimals on the problem like that. You could find a little error in that. It could give you an error there. I hope this video was helpful.